Hi, Transitional Math students. Mrs. Robinson here. Let's work practice benchmark chapter 12. I've posted a surface area and volume formula sheet. I believe I posted it in module 14. I'm not sure, somewhere. So go print that if you'd like to use it as a reference. And I still have a hole in my ceiling, so don't look at that. All right, let's go ahead and work the first one. What is the circumference of the circle? Round your answer to the nearest tenth. So let's look at the formula for circumference. Circumference is equal to the pi times the diameter. Remember, diameter is 2 times the radius, or the radius is half the diameter. So we have diameter. Great. Circumference is just pi times 6.5 inches. Now I'm going to go ahead and use a pi button on my calculator, or even 3.14. So I'm going to go 6.5 times 3.14, and I'm going to approximate this, and I'm going to get 20.41, rounded to the nearest tenth, 20.4 inches. So it's C. Okay, the diagram shows the region inside of a track. We're going to use this diagram. So if you have a track and the football field's in the middle and you have the two end sections, the track maintenance crew plans to edge the perimeter of the track. For approximately how many feet will they edge? Well, if you look at this, what we have here is a rectangle. And we want the perimeter of the rectangle with 35 as the length and 25 as the width. If we do the length here, we don't want inside here. We just want the lengths, because this length is the only piece showing in this length. So for the rectangle part, we're going to go 35 plus 35. And then we have two semicircles. So you can think of it, if you've got two semicircles, as a full circle. And you can see that length here for the diameter is 25. So what we really need is the perimeter of a circle, or the circumference. We know circumference is pi times diameter, and the diameter is going to be 25 feet. If we put this piece with this piece, we get the full circle, and we want this half and this half. So we're going to add the 35 and the 35 to the circumference of this circle, which will be pi times 25. And if you do that on a calculator, 25 times 3.14, you're going to get approximately 78.5. So 35 plus 35 plus 78.5, and add that up, 148.5, and it approximately rounds up, let's see, to how many feet? So we're going to round this up 1 to 149 feet. And it's C. All right, on to the next. All right, what's the area of this circle? We know the formula for area of a circle is pi times the radius squared. Now we have the diameter. The diameter is 6.5, and we know the radius is half the diameter. So we're going to divide this by 2. And the radius is going to be, that's not equal to, the radius is 6.5 divided by 2. And it's going to be, all right, 3.25 for the radius. So the area is going to be pi times 3.25, our radius, squared. Do that on a calculator, 3.25 times 3.25, and then multiply that by pi, and you should get approximately 33.16 or 33.2. And it's going to be inches, and it's going to be square inches because we're dealing with area. And the radius was in inches, and we squared it. So inches squared, always with area, square inches. All right, on to number 4. The inside region, oh, the diagram shows the inside region of the track. Okay, now this time instead of the perimeter, it's asking us the inside region of the track is grass. The maintenance crew mows the grass every few days. So we have to mow this, the football field part. What is the area of the grassy region? So now instead of the circumference or the perimeter, we want the area inside. So what we have once again is our rectangle part, which was 25 by 35. And then we have our two semicircles, which when we put them together, make a full circle with a diameter of 25. Now we want area, and we know the area of a rectangle is just going to be the length times the width, or 25 times 35. The area of a circle is pi times the radius squared. Now the radius right here is going to be half the diameter. So 25 divided by 2 is 12.5. So our radius here is going to be 12.5. That's our radius. All right. So pi times the radius squared, we're going to go pi times 12.5 squared. So we're going to take the area of the rectangle plus the area of the two semicircles, or the full circle, and that will be the area of the inside region. So if we go 25 times 35, we're going to get 875. And if we go 12.5 squared, and then multiply that by 3.14, or another approximation of pi, you're going to get 490.625. And then let's go ahead and add these two together. 875 plus 490. And you're going to get approximately 1365.625. And if you round this to the nearest foot, that's a 6, so you're going to round that up to 1366, and it will be feet squared, its area, and that's C. Okay, a small refrigerator has a volume of 104 cubic feet. The base of the refrigerator is a square with side lengths of 4 feet. What's the height? So here's the deal. We got a refrigerator here. It's a, let's see if I can do it like this without making it look like it's laying on its side. It's okay. All right, here's the refrigerator, and its height, I know that doesn't look square, but okay, so its base, if you look at its base, it's going to be 4 feet by, oh, it is lying on its side now, 4 feet by 4 feet. And then its height, if you want to do right here, the height laying on its side. We know volume is length times width times height for any kind of prism, rectangular or square. The length and the width happen to be the same, so we're going to go 4 times 4 times the height. They give us the volume is 104, so we say 104 cubic feet is 4 times 4 times the height, and solve for the height. So 104 equals 16 times the height. Divide both sides by 16. And you're going to get the height is, let's go 104 divided by 16, 6.5. And that will be in feet. So it's C. Once again, 4 C's in a row this time. Okay, find the volume of the rectangular prism. So once again, like what I just drew, but I'm an awful drawer. So let's know that volume of a prism is length times width times height. So we have 6 times 4, and then 3/4. If you want to divide 3 by 4 on a calculator, you'll know it's 4.75 times height, which is 11. Just go ahead and multiply that all out. 4.75 times 11 times 6, and you'll get 313.5. It's centimeters cubed because it's volume, because this was a centimeter, that was a centimeter, that was a centimeter, and you multiply it 3 times, you get centimeters cubed. And it's B. All right, a cylinder. So if we want a cylinder, we want to find the volume of a cylinder. We're finding the volume of each of these figures. And let me try drawing that maybe a little bit better. The volume of a cylinder. All right. And we know volume of a cylinder is the area of the base times the height. And sometimes on the worksheet, I like to write volume. The area of the base is a big B. If it's just the base length, I write little b. but area of the base is the big B times the height. Now your base is a circle. If your base was a square, the area of the base would be length times width, or a rectangle. But when it's a circle, that base is pi times the radius squared. That's the area of the base. Times the height. And we know the radius here is 7, and the height is 42. So if my height's 42 and my radius is 7, I'm going to go pi times 7 squared times 42. And that will give me my volume. Now that's just a calculator. If you go 7 times 7, you get 49. 49 times 42 times pi. And we're going to round this to, looks like 1 decimal place except for that one. It's 6465.39 or 0.4. And it would be D. And that would be inches cubed because, once again, it's volume. You did 7 inches times 7 inches times 42 inches. You did inches 3 times. And that's D. Now, if you have a square or rectangular pyramid, you know, just a regular prism, it's length times width times height, or length times width is the area of the base. So big B for area of the base times the height. But we have a pyramid. It's like you cut off 2 sides, or a third of it. So we do a third of the area of the base times the height. All right? So instead of doing length times width times the height, which they give me right here, is 9. Not the slant height, the actual height of the pyramid. Don't get that confused with the slant height. The slant height would be on the face of the pyramid. Okay, so the actual height of the pyramid we know is 9 inches. Now big B, meaning the area of the base, would be this times this, but they went ahead and said, oh, the area of the base is 29 inches, so I don't even have to find that out. I'm just going to plug in 29 for the area of the base. So 29 times 9 times 1/3. Now you can just do this on your calculator. 29 times 9, and then divide that by 3, and you're going to get the volume is 87, and that would be in inches. So B. Now the cone, its related would be the cylinder, and we know the cylinder, the volume is the area of the base times, I'm getting it rings, times the height, right? The area of the base times the height is the volume of a cylinder. Well, if you look, it's like we cut off a third of the cylinder here. Cut off a third of it. And you can do the little circle at the top. But just so you get the idea, we cut off a third of it. So instead of the volume being the area of the base times the height, big B for area of the base, which is pi, because it's a circle, once again it's a circle, pi times radius squared would be the area for the base, times the height, that's the volume of a cylinder. Now the volume of a cone is just a third of that, a third of the area of the base times the height. So we're going to go a third pi, and the radius squared, the radius here is 12, 12 squared times the height, not the slant height, not on the face, but the actual height, which is 20. That's supposed to be a 12. Now this is a calculator problem, so I'm just going to go 12 times 12 is 144 times 20, and then I'm going to multiply that by pi, and then I'm going to divide that by 3. And that's going to be approximately 3015.92. And if I round that to 1 decimal place, 92, that'll just stay the 9. So 3015.9. And that will be meters because that was meters, and I squared it, and then that was meters. So there's meters cubed with volume. And it's C. Lots of C. Okay, we got to find the volume of a sphere. So using that formula sheet that I gave you, the volume of a sphere, and I'm just going to do it like this for a sphere. Okay, so the volume of a sphere is 4/3 times pi r cubed. All right, they give you the radius, so it's really simple. Spheres are the easiest, I feel like. 4/3 times pi times that 3, and then you cube it because you're dealing with volume. So 3 times 3 times 3 is 27. Then we multiply that by pi, and then go ahead and multiply that by 4, and then divide that by 3, and you're going to get approximately 113.09, and you can round that to 113.1, and that would be centimeters cubed because that's centimeters and you're cubing it. So it's really 3 centimeters. If I was accurate, I would write it like that. All right, so it's once again C, lots of C's. Which figure has a base that's a circle? Well, a sphere doesn't really have a base. It's a globe. A prism, that's like this, no. Pyramid, well, no, because a pyramid has a square or a rectangle. If it didn't, it would be a cone. So a cylinder has a base that's a circle. C again. Okay, let's go on to surface area. Surface area is a little trickier. Now you can do surface area in 2 ways. Surface area, I can go ahead and find the area of this face, then the back face, then the top and the bottom are matching, then the front and the back. I could just go ahead and find the area of each of these square faces. Okay, not the volume, we're just looking at the faces. Or I can use one of my formulas. Sorry, I just wrote V. Surface area for a prism on the sheet, it's the perimeter of the base times the height. So I would go around the base and figure out the perimeter and then multiply it by the height. Then I'm going to add on 2 times the area of the bases. That's going to be the surface area here. And the reason is it's like a shortcut. By doing the perimeter of the base times the height, I get the lateral area. Because if I do the perimeter of the base times the height, it's like this base is 7 times the height of 4. This base of 5 times the height of 4. This base of 7 times the height of 4. This base of 5 times the height of 4. Well, I could just add all of these bases up and do the perimeter of the base times 4 once. That just makes it easier. This is the lateral area, okay? The perimeter of the base times the height. And then I have to do the top and the bottom, which is 2 area of the bases. So the perimeter of the base is going to be 5 plus 5 plus 7 plus 7, 5 plus 5 plus 7 plus 7. And then I multiply that times the height. Now, if you're one that likes to go, I'm going to go 5 times 4, and then 7 times 4, and then 5 times 4, and then 7 times 4. Go ahead. Or you can go 5 plus 5 plus 7 times 4 once. All right. And then that height is 4 plus 2 times the bases, the area of the base. So 2 times, well, the bases are the bottom and the top. The base is 5 times 7. It's the same on the top. So 2 times 5 times 7, 2 of those. All right. So add this up. If I go 5 plus 5 is 10, 7 plus 7 is 14. So I'm going to go 24 times 4, and this is going to give me 96, plus 5 times 7 times 2, 70. And then add those 2 together. 70 plus 96 is going to give me 166. And these were all in centimeters. And we're going to square the centimeters because we did this centimeter times this centimeter. This centimeter times this centimeter gives us square centimeters when you're dealing with area. Okay, so 166 centimeters squared. All right, on to the next. Okay, the surface area of the cylinder is a little trickier to figure out. Here's a formula that works. You're going to go 2 times pi times the radius times the height plus 2 times the area of the base. Now the base here is a circle, so the area of the base will be 2 times pi r squared. That's what the base area is. Big B stands for area of the base, and pi r squared is the area of this particular base. So the surface area is 2 pi r h plus 2 pi r squared. Now where does that come from? It's here. If I were to take a cylinder and I was to slice it open, okay, let's say you have a paper towel roll and you slice it and you roll it out. If you roll it out, you actually have a rectangle. Slice a paper towel roll and roll it out. And when you have that rectangle, if I were to roll this out, so it was like this, okay, it would be base times height to get that lateral piece. I cut this open and I roll it out and it looks like this. Well, the base here is going to be here. The base is actually the circumference of the circle. See, right here. So the circumference of the circle is pi times diameter. Diameter is 2 radiuses, or pi times 2 radiuses. That is this, okay? And then the height here. So to get the lateral area, this is the lateral area plus 2 bases, okay? The top and the bottom. To get the lateral area for a cylinder, slice it open, you need the circumference, which is 2 pi r, or pi times diameter. 2 pi r, that's the base, the circumference of the circle, times the height. 2 pi r times the height. So that's where the lateral area of the circle or the cylinder comes from. Roll it out, you can see the base is the circumference of the circle times the height. 2 pi r times the height. And then 2 times the top area and the bottom area. So 2 pi r squareds. So let's go ahead and plug in our numbers. 2 pi, and then the radius here is 6 inches, so 6. And then the height here is 6. Plus 2 times pi, once again the radius is 6. And we're going to square it. All right. Well, 6 squared is 36. 36 times 2 is 72 times pi. So let's just write this as 72 pi plus 6 squared is 36 times 2 is 72. So it ends up being 72 pi plus 72 pi. So the lateral area and the top and the bottom happen to be the same. And then I'm going to go 72 pi's plus 72 more pi's is 144 pi's. And then, sorry, so it's not in terms of pi. I'm going to multiply 144 times pi, and you get about 452. That is ugly. Okay, 452.38. You could round to 0.4. 452.4, and this is inches. So you multiply it, you get inches squared. Same here. Inches, you square it, you get inches squared. And inches squared plus inches squared is inches squared. Okay, always square inches or square units. All right, on to the next one. Water is stored in a cylindrical tank with a diameter of 34 feet. The surface area of the tank they give us is this. What is the height of the tank? So now we got to do a little solving. So let's see, we've got a cylindrical tank. Let's just draw a little picture here. Okay, and pull that down. And then they give us the diameter is 34 feet. So I know my radius, 34 divided by 2, is going to be, so let's do the radius in the circle at the bottom. The radius is going to be 17. We want to know the height. They give us the surface area. Okay, so we know the surface area for a cylinder. Remember, if we slice it open and roll it out, it's the circumference times the height. That's the lateral area. So circumference is pi times diameter, or 2 pi times the radius. Now, because we have the diameter, let's actually just do pi times diameter. That's easier. Pi times diameter, and then plus the top and the bottom, plus 2 times the area of the bases, which are pi r squared. Okay, there's our formula for the surface area. They told us the surface area is 4165.8. We know the diameter is 34, so we're going to go pi times 34 plus 2 pi, and we know the radius is 17, and I just made a mistake. Pi times diameter times the height here. The lateral face is the circumference of the base times the height. So the surface area will be pi times the diameter times the height. This will give us the lateral area plus 2 times pi times the radius squared. Sorry about that. I just realized doing this times the height, it's like the base times the height to get the lateral area, and then the top and the bottom. That's my top and bottom. That's my lateral area. So pi times diameter times the height. So pi times the diameter is 34 times the height, which is what I'm solving for. I'm going to put it in blue. All right. So sorry about that. Dropped that out. Shame on me. Okay. Plus 2 times pi times the radius squared, and the radius is 17, so 17 squared. Let's go ahead and simplify what we have here. I'm going to go 17 times 2, and then multiply that by pi, and I'm going to get here 1815.8. Let's just do that. And then here 34 times pi times h, so I'm just going to go 34 times pi and round that out. It's 106.8 approximately times h. And then I'm going to add that to this. Now I can't add these together because I have a variable here and I don't have that same variable here. This is 1815.8 plus 106.8 h's. So I can't add my h's to my constant because I have that variable. But what I can do, we know it's equal to 4165.8. What I can do is I can subtract this to this side. So I'm going to go ahead and do my subtraction. Subtract this to this side. So by subtracting these, if I do, let's see, 4165.8, and I subtract off 1815.8, I'm going to get 2350, and that's going to equal 106.8 times h. I'm solving for h. To get h by itself, I need to divide both sides by 106.8. And I'm going to get h is equal to this divided by this. So 2350 divided by 106.8 is going to give me, and I'm going to approximate this, 22.03. And I'm just going to approximate it to 22. And it is in feet. I dropped off my units as I did my work, but it is in feet. So 22 feet is your height. All right, guys. Okay, I'm trying to draw a little square pyramid here for this one. Okay, there we go. Find the surface area of the square pyramid. And they give us the base edges are 6, so this will be 6 and 6. The slant height is 10. Slant height means that's the face. So it's not the height in the middle like we would need with volume. It's on the face, so it's here. Let's see. Maybe it would serve better to draw it on the front triangle. It's here. It's on the face of this triangle. Okay, that slant height is 10. Okay, now to find the surface area of this, you can see I have one base, one square base. So the surface area is going to be one base, one area of the base, which here, because it's squared, happens to be side squared. So it's going to be the side squared. If you want to make it work for any rectangular, you do length times width, right? That's the area of the base. Plus, you have 1, 2, 3, 4 triangles. So you could do 4 triangles, and you have a triangle. The area of the triangle is 1/2 the base of the triangle times the height of the triangle. Base meaning little b for base, and height would be that slant height or the front. Now the area formula that we give you on the sheet looks like this. The surface area formula. The surface area formula is going to be one base plus 1/2 the perimeter of the base times the slant height. L being the slant height, not H. Now, this is the height of the face of the triangle. This formula happens to be the same as this formula. I'm going to do half. Instead of the base times the height for each triangle, I'm going to do the perimeter of the base. So I'm going to do 1/2 6 times 10 for this one, 1/2 6 times 10 for that one, 1/2 6 times 10 for that one, 1/2 6 times 10 for that one. Or I could just do all the bases together times the slant height times 1/2. That's what this gives us. Or you could do each triangle and then there's 4 of them. Either way you want to look at it. I prefer this. So I'm going to do length times width, 6 times 6, plus 1/2. Instead of doing each triangle individually, I'm going to do the perimeter of the base. 6 plus 6, which is 12, plus 6 more, which is 18, plus 6 more, which is 24. So 24 times the height of the triangle, which happens to be the slant height of my figure, 10. Now if you had done it this way, you would do 1/2, the base is 6, the height is 10. That's one triangle and you have 4 of them. Now if you can see, 1/2 times 6 times 10 times 4 is going to give you the same as 1/2 times 24 times 10, because 6 times 4 is 24. So either way you do it. Okay, so the area of the base plus 4 areas of the triangles. And let's go ahead and do that. 6 times 6 is 36, plus half of 24 is 12. 12 times 10 is 120. 120 plus 36 is 156. And that will be centimeters squared because it is area. And that's 15. Let's do one more. We got the cone. All right, your cone, you want the surface area of a cone. Well, you got a circular base, so you know with a cone, you have to have at least one area of the base, which will be a circle. All right, and so surface area is going to be the area of the base, which we do big B, plus the lateral area, which is a little harder to figure out, plus the lateral area. It's a little harder to figure out with the cone. So the surface area is going to be, the area of the base is pi times the radius squared, plus the lateral area for the cone is going to be pi times the radius times the slant height. Okay, so do we know the radius? They told us the diameter was 6, so our radius is going to be 3. They gave us the slant height, which is 8. That's not the height of the cone. You have to have the actual height of the cone to figure out the volume. Okay, we're not looking at volume, we're looking at the slant height, which is what we want to find. So it's basically we're going to do the circumference times the slant height. Okay, so we're going to go pi for the base, the radius is 3, we're squaring it, plus pi times the radius, which is 3, times the slant height, which is 8. And that's your surface area for a cone. So make sure you know the surface area for a cone. It's the area of one base plus the lateral area. And the lateral area is pi times the radius times the slant height. And that is on that sheet that I gave you. All right, so we're going to go 3 squared is 9. And then we're going to go 9 times pi is 28.27, so 0.3, plus 3 times 8 times pi is 75.4 approximately, and add those together. And you're going to get approximately 103.69, which would round about to 103.7. It is surface area, centimeters squared. And you have 103.7 centimeters squared, it's B. All right, guys, that is the end of this. You may use your surface area formulas that I posted. I believe I posted them in module, let's see, module 14. So use those, make sure you understand how those work, and good luck. Let me know if you have any questions.